Hey everyone, my name is Jeremy. I'm a product manager for DB SQL and performance.
And my name is Alex, also product manager on security. And before we get started, just want to say thank you. I know it's Thursday, it's 5 o'clock. Y'all probably have flights home later today or early tomorrow. So really appreciate you staying late and hearing about this talk.
Yeah, and so just to kick it off, we have a talk today about how we see the biggest customers at Databricks scaling their DB SQL performance, observability, and security. So just go kick it off, the normal product safe harbor statement. And so before we jump in, who's this for? This is really designed for those of you in the crowd who are considering adding new workloads or new users, and you want to understand kind of what are the best practices to do that. And in that, there's three kind of key pillars that we've found that the biggest customers use. And one is they focus on performance. They want to make sure that the latency stays good. They want to make sure that they're observing what's going on. And lastly is they want to make sure it's a secure environment. So first, we're going to jump right into it. We'll kick it off with workloads. How do you scale workloads through performance? And so some of you may have seen this, but Databricks SQL is designed to be a warehouse that can handle all OLAP workloads. It's designed for the small workloads and the big workloads. And it's really through 5 kind of key feature areas. We're going to go through each of those. I'm going to walk through the best optimizations to make. And by the way, I want to just say, this is called, these 5 features, if you hear this referred to, this is called the Databricks DB SQL AI engine. All right, so the first step in the AI engine is that we want to learn from your data. We want to learn about your data. And so this is where predictive optimization comes in. Many of you may have seen this feature. It's a new feature that's coming out. It's constantly being improved. And what it does is it collects detailed stats on your tables, the partitions, the data layouts. It looks to how it can optimize file sizes. It tries to figure out what data doesn't need to be there anymore and deletes and vacuums that data. And it's very easy to enable. You can simply alter schema name, database name, enable predictive optimization. And that data now will flow directly into the query optimizer. Remember, SQL is a declarative language, meaning you tell SQL what data you want and where the data is at. And the plan comes from DB SQL, the query optimizer specifically. And what we found is that when we have inputs from predictive optimization, this part of the plan can generate an 18% better latency for queries on our benchmarks that we've tested. This is generative in nature, meaning that it generates hundreds or thousands of plans, and it chooses the best one. And kind of best of all is that if it realizes somewhere in there that it's not the optimal plan anymore, it can pivot and pick one of the other optimal plans or regenerate. And for this step, as long as you have predictive optimization enabled, there's no action needed. This part is on its own and it takes care of itself. The next step is data retrieval. So now that we know about your data, we've generated a good plan, the next step is we've got to go get the data and we've got to rapidly prune, filter, and get that data from cloud storage. This is where this is enhanced by liquid clustering, and it's enhanced by predictive I/O, meaning that we can do point lookups very quickly with these ML predictions. And this section, the key tip here is what we see in the biggest companies is that they enable liquid clustering, they cluster by the 4 columns, and they use either a pro or a serverless warehouse where predictive I/O can kick in. Next is why we're able to, now that we have the data, now we've got to start executing, and this is where Photon comes into play. Photon, if you know anything about it, it's a vectorized execution engine. It works in memory, and some of the optimization techniques that we use, like for example, it was mentioned yesterday about GPUs. There's a lot of different things and tricks that are used to make these queries much faster. There's no code change necessary, so if your query is eligible for Photon and you're using DB SQL, it'll automatically drop into Photon. Nothing is needed to make that fast. And lastly, now that we can execute a single query well, the next step is what happens when you have many queries. And so this is where intelligent workload management comes in. This is more of a serverless feature. And what happens is that if you have lots of queries coming in, we can rapidly upscale, downscale, spread the queries out, and all in the idea that we want to protect the query latency and autoscale as needed. The tip here is use serverless with autoscaling, especially for any BI or any query workload where you need to protect query latency. So I want to announce some of the latest benchmarks that we have, and the first one is for our scalable ETL. So if you can see here, we benchmark against one of the leading cloud data warehouses, and you can see at 100 gigabytes, we stay about the same, or we're about the same in price. But as we scale up, Databricks has continued to bring that down, and we're down to around $488 for a 30 terabyte, while our competitors are scaling at about 9x. So the goal here is that we are not costing more exponentially, that it's linear or sublinear. Next is the highly concurrent BI workloads. So you can see here again, as we are continuing to add more users on this x-axis, our warehouse will protect query latency, where the red bar, the blue bar continues to climb and regress in query latency 10x. To show kind of what this looks like in production, like these are all synthetic benchmarks, and everyone's going to show different ones. This is what's actually occurring for our customers. We have a team of data scientists who actually are building performance indexes to look and see what is the performance improvement over time. In the last 2 years since Databricks SQL launched, the customers have gotten, or the queries have gotten 73% faster on average over the last 2 years with nothing needed to be done at all from the user standpoint. So kind of just recapping, what do you need to do to scale your DB SQL performance? It's very simple. Use serverless with autoscaling enabled. Enable predictive optimization. Enable liquid clustering, and nothing else. Everything else will get faster on its own. The plans will get better over time, and you'll benefit from the same features that the biggest customers use and make the workloads fast. All right, next we're going to cover observability. So now that you have your workloads on the warehouse, next thing you want to know is, okay, are my users having a good experience? What about cost? How do we track that? And so DB SQL has 4 out-of-the-box system tables now. There's a billing table, warehouse events, query history, and then this quarter we're going to be releasing the warehouses table. All right, so the first kind of key thing that we see customers do is they want to know about cost controls. And specifically, they're looking for proactive resource management. So what that means is that they want to know about long-running warehouses. So for example, if you have a warehouse that's been running greater than 10 hours in a day, they want to get an alert on that. If they have warehouses that are running at unusual times, like on the weekends, they want to get alerts, proactive notifications on this. And then lastly, they want to know about warehouses that have been upscaled for a really long period of time. And just to kind of give you an idea, I'm going to give you guys a link to some queries that you can use. But this is what this would look like in practice. I've blurred out the warehouse IDs, but essentially a very basic query from a system table. It has a warehouse ID. You can get the running hours. And you can set an alert to say, hey, if this is greater than 10, send me an alert, send a Slack message, tell me what's going on, because this is what's going to be driving up cost. Next is they want to know about individual queries that are having performance issues. So specifically, if you have a query that's spilling to disk, or you have a lot of shuffle inside of a query, we all kind of know that there's the query that can be written on QPS logs that limit unlimited query, and suddenly you start bottlenecking the warehouse. And for this example, we want to show that you can query the query history, and you can look at disk spill, you can look at shuffle operations, you can sort by the top N queries and execution time, and you can start your investigation of what do we need to be focused on to get faster with just this table. This is the number one, just to kind of side note, when I talk to customers who are going for cost controls, this is the number one thing we do first. We go to query history, we sort by spilled local bytes, we sort by execution time, and we start highlighting these queries as the main ones to go focus on. Next is user experience. So now that you have hundreds or thousands of users that are using your warehouse, the next step is that you want to know about when suddenly the warehouse becomes overloaded or burdened. Maybe it started off as a warehouse that wasn't used a lot, but suddenly they've been continuing to add more and more users to it. And what you want to monitor for is increases in warehouse usage, changes in total throughput, and changes in queuing. You can do this again through the query history table, and it'll produce a report simple as this. This is one of the most common reports that people set up, which is just the count of daily queries on a warehouse. If the number changes over a significant amount over a month period of time, they get an alert. And then next is user experience for latency don't there's probably a time when you have gotten a call that says, hey, my queries are running slow. And you don't really have a lot of insight into, okay, is this everyone is having this issue, or is it just one person? You can get this information easily from query history table. You can create a report that looks like this. You can get a percentile of the P50, P75, the P99, and you can look to see what is the average experience that customers are having at the tails, at the middle, and you can set up reports on this, you can do monitoring on this, and it's very simple to do. Again, I'm going to give you 2 links here. So the first one on the left, this is the help document that we have that's public, but on the right is pre-written queries, and we will soon launch a dashboard that's going to have all of these built into it. But these are the #1 queries that we see customers use today. On the right-hand side, pre-written queries, just grab that. All right, next is security with Alex.
Awesome. All right, thanks, Jeremy. So Jeremy talked about performance and about observability, and I'm going to talk to you today about security. We use security here a little bit loosely. So when we say security, what I'm actually going to cover is identity, governance, network security, and compliance. And the theme that should emerge if I do a proper job is that usually when you think about security, you think about complexity. And we've spent a lot of time trying to make configuring all of these things as simple as possible so they don't have to be your focus. So you can focus on the fun stuff like data engineering and data warehousing. So the theme that should emerge here is ease of use as we talk about all 4 of these pillars. And again, I could probably do a dedicated hour or more on each one of these pillars alone. So this is going to be a very high level sort of best practices at scale that our customers have adopted. And then, you'll be able to go into more depth with all the different features we have with public documentation and blogs, et cetera. So we'll start with identity and governance. So when we think about identity and governance, kind of the path that I'll walk you through over the next few slides is, first we need to be able to grant users access. Once they have the access, we also want to make sure that the tools that they're using have the proper access. You might be using BI tools or something to talk to your SQL warehouses, and we want to make that access simple for you. Great. Once we've handled access, we want to keep syncing identities so everything is current. The world is dynamic. You don't want to have to think about which user belongs to which group, should be able to access what. It should just work seamlessly for you. Once we figured out the access bits, we'll shift focus a little bit to talk about permission management. So, we've established the access, but what about all the, permissions and fine-grained access controls that you need, both to manage permissions to catalogs as well as actually secure data access. So get all the way to row-level security and column-level security. Okay, let's start with access. So this is, those 4 pillars I just showed. We're just going to talk about the first one here. So configuring access and single sign-on for all of your users, very importantly, with multi-factor authentication. I'm a little bit, it's a little bit hard to see the audience, but I can see shapes generally, so I will see a raise of hands. Raise your hands if you're using single sign-on already configured with Databricks. Awesome. I saw almost all hands go up, so that's fantastic. Previously, when you configured single sign-on, you had to do this at the workspace level, right? You had to do it over and over for each workspace. The message here is, provision this once at the account level. So you should be able to go to the account console, provision single sign-on, provision it for all future workspaces to then inherit those same properties. So you can do federated authentication with whatever identity provider you use. Databricks supports most of them, if not all of them. So once you configured single sign-on for your users, very importantly, cybersecurity attacks are everywhere, and you don't want to be subject to them. So multi-factor authentication is a very, very, very important piece to that puzzle on top of the single sign-on. How many of you flew here to get to the conference? Okay, again, most everybody. When you flew here, you went into the airport, you went through security, you presented your boarding pass. You probably also presented your ID, right? Why? Because someone could effectively steal your boarding pass and pretend to be you. So you need a second form of authentication to prove you are who you say you are. Same concept with multi-factor authentication, right? If you want to protect against your credentials being compromised or stolen, you add this multi-factor auth as a second form of authentication to say, really, this is me. I'm not, I didn't steal someone's boarding pass. Okay. Fantastic. So our users have access to their SQL warehouses, but what about the tools that they're using? So the next message is, enable single sign-on with OAuth for your favorite BI dashboards. So the example I'll show you is with the Tableau desktop, and what should emerge from this example is that you don't have to play with OAuth tokens anywhere in this flow. You use the same single sign-on method, to do exactly this. So you go into your Tableau desktop app, you choose Databricks, and you choose the authentication method with OAuth, let's say with Azure Active Directory, which is Enter ID these days. And as soon as you've done that, right, you get redirected to your identity provider. So you sign in to continue with your username credentials. Hopefully, again, you're using multi-factor authentication, and that's it. You now have this BI tool now has access to your SQL warehouses, and you never had to touch an OAuth token to get it. It was implicit in that flow. So far, so good? Awesome. Okay, so we have granted access to our users, to our BI tools. What about syncing identities, right? Your organization, your workplace is dynamic. Employees come, employees go, they shift jobs, they need access to different, they need to be in different groups or removed from those groups so that they have access to different workspaces and the underlying schemas and things attached to those workspaces. So this is where syncing identities to the account is very important, so you don't have to go manually manage every user and what access they have to what workspace. So first things first, again, in your identity provider where you've configured single sign-on, that's where the user and group information is stored. You want to pull that information, or in this case, push that information with Databricks using the SCIM APIs. And so at the Databricks account level, SCIM lets you seamlessly get all of the updates. So all of the updates from these identity providers are pushed to the SCIM API, and that dynamically updates everything that you need downstream. With Azure, it's even simpler. It's seamless. It's a pull method with the Graph API directly, so you don't even need the SCIM API. But regardless of the method that you're using, that allows you then to manage identities centrally. So if a user comes, user joins, user leaves, that just updates to your group automatically, and then in turn, admins have already granted user or group specific access to their workspaces. Okay. So we've given users access, we've given BI tools access, we've dynamically updated all the groups that we need. What does that do in turn? In turn, it lets us govern our data, right? So now you can restrict access to authorized environments based on those exact same groups that we just talked about that are dynamically updating. So you can associate those groups to which workspaces they have access to, as I showed you on the last slide, and now on this one. And then in turn, those workspaces have access to various catalogs and schemas, all governed by Unity Catalog. So by configuring, by creating that access, by creating those dynamic permissions, now you've got the ability to just seamlessly update who has access to what. And then at the table level, all the way down to row level security and column level masking, sometimes you need this to be differential as well, right? So for a particular row, you may only want to show specific rows and have them returned in a query if a user meets certain guidelines, right? In this example on your left, you'll see if the user is a member of a group called admin and if they're in a particular region. So row level security allows you to do that. Similarly, masking or redacting sensitive columns, exactly the same purpose, right? So you can create the same kind of SQL UDF for user-defined function to say, I will only allow this, or I will in fact mask this column if these certain parameters are met. And then the exciting announcement, if you were in the UC talk earlier today, is that we're bringing ABAC, or attribute-based access control, to this thing. So you don't need to go manage masking different columns, on a column-by-column basis. You can create these attributes and then tag specific columns with them, and then all of that masking will just dynamically apply to those columns. So, thinking about scale and how you scale out, that is a huge tool in your belt. Okay, that wraps up the identity and governance section. So hope that all made sense and resonated. We talked about giving users access, giving BI tools access. All of that can't happen unless the underlying network fabric is there, right? So now I want to talk a little bit about networking and network security and what we're doing in that space. So I'm going to zoom out for a second, and in this slightly funky diagram where things go right to left instead of left to right to keep you on your toes, you've got in your classic sort of architecture where you manage the compute resources, you had your clients, both the users and those BI tools, talking to the Databricks control plane that was managed, of course, by Databricks. And then that control plane was talking to your classic non-serverless compute workloads. And in turn, those workloads were talking to whatever resources that you needed them to talk to. That paradigm changed with serverless, right? It changed because now we're responsible for that serverless compute. You get all these benefits of warm pools, fast startup times, all the features that Jeremy talked about. But now, that connection between your serverless compute and your assets becomes a very important connection for us to secure on your behalf. That's probably where 90% of my job is these days, because I'm the network guy. So here I want to talk, I blew up those locks to talk about these two particular connections. There's lots of connections into and out of Databricks. Happy to talk to you about all of them, but again, we just don't have time for all of them today. So I want to talk to you about clients connecting to the Databricks control plane, and in turn, serverless workloads, in your case, SQL warehouses, talking to storage, talking to the internet. So let's start with that first one, your users and your clients talking to Databricks. We already talked about the airport example and why it's so important to configure single sign-on, configure multi-factor authentication. Okay, now you made it through security, right? You got some access token in exchange. The access token was that you're now allowed, into the terminal. At that point, nothing really protects you from, having those things stolen from you. Like you've already made the first authentication pass. And so now this is where networking becomes very important to layer in with authentication. So we covered number one. Number two is exactly for this purpose, right? Mitigating against token replay risks. So you've made it through the gate and now someone steals your token. How do you make sure that they can't go replay your token or effectively pretend to be you? And that's why, there's these two different technologies. If you're using something called private link, and maybe I'll ask by show of hands, how many of you, if you know, are using private link today? Okay, that's an awesome number of people. For those of you that aren't or may not know what private link is, because it took me like a month to figure it out when I joined the company, private link, think of it as a dedicated private connection that never has any kind of public IP. And if you're accessing a resource outside of your network or your account, it effectively emulates as if that resource is sitting inside of your account because there's no public IP that it's using to talk to that resource over. So many organizations have a security or compliance requirement to use private connectivity. If you're using that, right, this is that network binding on top of that credential because it's not enough to say, here's my username, here's my password, here's my MFA. I must also egress through this private endpoint for any connection into Databricks. If you're not using private connectivity, public connectivity has a great solution as well, which is IP access lists. I'm sure a lot of you folks are using them today, but if you're not, what that does is it binds that traffic again to a particular set of IPs that you can come from. So your IT department would have done something like, I'm Alex, I want to access Databricks, I can authenticate, but if I'm not coming from this known set of IP addresses representing my trusted company's network, then I will be denied access. So very, very important, to mitigate against cybersecurity attacks and the like is to use SSO, use multi-factor auth, and then take all of that authentication layer and tie it to a particular network control. Okay, so we covered the user network connectivity. What about our serverless stuff connecting to your resources? So when it comes to that, I want to cover storage, and I want to talk a little bit about internet and what we're doing here. If you're using Unity Catalog, you get all of the credential benefits that we'd already covered previously. So here I want to talk a little bit about network security. Specifically, there's two important things to keep in mind. One is that all of the storage access that you configure with Unity Catalog, this is going over the cloud provider's backbone. So effectively, the traffic, it doesn't egress to the internet. It stays private or on the backbone of the cloud provider, and it's all encrypted with, the latest sort of protocols, so TLS 1.2 or higher. On top of that, if you're using Azure today, we've already announced this, it's coming on the other clouds, but we've announced a dedicated private link that you can create from your serverless workloads, going to the storage account that you need to talk to. Even though it's a multi-tenant serverless environment, these private endpoints that you create are bound to your VM specifically, at runtime when you issue a SQL query, for example. The other big thing that we announced, working with the Azure team, is that this will be free of charge for you for all data processing. If you know private link, you can get expensive. There's per gigabyte costs and there's per hour costs for those endpoints. The per gigabyte costs are where the unpredictability are and where a lot of the cost usually is, and that part is totally waived. So really, like no excuse to not start using these today for storage if you've got a security or compliance requirement that tells you you must go over private link. That's storage, great. We've covered storage, and using UC, we're even able to create those fine-grained access controls saying inside of those storage accounts who can access what. But what about the rest of the resources, right? And that's where we just announced actually earlier this week how we secure egress to the internet. So one thing I should say up front for anyone who's like, I need to secure access to the internet, is that DB SQL by default doesn't have access to the internet. So you're already secure in that regard. Now this feature will be relevant for other workloads and DB SQL in due time. What serverless egress controls allows you to do is to say, I will not allow outbound connectivity to the internet from my various SQL warehouses or other compute types. Eventually, we'll have something that lets you, FQDN filtering type controls that will say no internet access except to these particular resources. Right now, we've kicked off a preview that's just, turn internet on or off. And this will be very important for model serving, DLT, notebooks, but even for SQL, right? I said today it doesn't have access to the internet, but features like network UDFs are coming, which will provide that outbound internet connectivity. So very important to figure out what your security posture is with outbound internet access and lock that down. And then, of course, the important thing to say is access to UC is, over a governed path that you define is still always allowed, so you won't accidentally shut that off. Make sense? Cool, still see some head nods, that's great. Okay, so we've done the authentication bit, we've done the governance bit, we did the underlying networking that made it all secure and possible. We've taken care of security. What about compliance? So compliance, it's essential. Regardless of what industry you're in, you could be in healthcare and you're working with PHI data, you have to meet these standards of HIPAA and high trust. If you're a government organization, a federal agency or a company or contractor working with the government, you have FedRAMP and potentially DoD, different IL levels that you have to comply with. And if you're in the financial sector, you have PCI because you're working with credit card information, social security card information, and the like. But compliance can be very overwhelming, right? You want to know what controls do I need to actually put into place when I'm processing that regulated data for which those standards exist. And how do I make sure I correctly implement those controls? And once I've implemented those controls, how do I make sure that they remain correctly configured, that there isn't a misconfiguration or something that introduces a vulnerability? So that's where I jump to this slide of how Databricks actually helps with compliance. So the first thing to say is that we have this compliance security profile that you can see a small screenshot of. That is kind of your one-stop, 4 clicks, I counted, way of choosing the standards that you must comply with. You can set this at the account level. So you can say configure, I must adhere to HIPAA or PCI. And as soon as you do that, right, we make that magic happen in the background. If you need to use a particular type of VM, we'll make sure that that VM is used. So you think about the problem space, about the standard you must comply with, and we do the translation on your behalf. Now, the other important message on this slide, of course, is DB SQL is available with all the major certifications that you need across the clouds and on AWS GovCloud, which we just announced yesterday. Actually 2 days ago and then again yesterday. And the final thing to say is that once you configure this, if you configure the compliance security profile that I just showed at the workspace level, you can't reverse it. And that's, that was that last question we had about how do I make sure I stay compliant? It's easy. Once you've set it on a workspace, it's there forever. So no chance of misconfiguring or having somebody revert that change. If any of this resonated with you before I back all the way up to everything that we talked about, kind of the call to action in the security space, we are doing a lot of different previews in this intranet on-off space, providing various private links, new compliance standards, all the like. Scan this thing. There's like a 10-second survey that will let us get in touch with you. So if any of this resonated, please fill that out. And with that, what I want to jump to is just conclusions. We started with this slide without the green text. So we'll end with the slide again now with the recommendations. So Jeremy talked about performance. He talked about observability, and I covered security. Kind of the takeaway message, if you leave with nothing else, is, under performance, you should enable predictive optimization, enable liquid clustering, and use autoscaling if you're using serverless with your warehouses. Observability, Jeremy talked about those 3 system tables that are already available, with the 4th one actually coming here momentarily later this quarter. So start using those different system tables for monitoring and for alerting. And then finally, in the security space, we talked about identity, sync your identities, provision your users and their BI tools to make that seamless and secure. Use Unity Catalog to secure access to your data and those fine-grained access controls with ABAC when it's there. And then finally, on the internet connectivity side and the private connectivity side, enable those private connections to your storage accounts and disallow unauthorized access to resources on the internet. And with that, we have some time left for questions. So again, thank you for staying late on Thursday, and happy to take any questions.